Today's problem, balancing consonants and vowels ratio, difficulty medium. This must be a new problem. I see there's only like 33 submissions. Usually submissions are in the tens of thousands, hundreds of thousands. You are given an array of strings where each element consists of lowercase English letters. You need to find the number of balanced strings in the array, which can be formed by concatenating one or more contiguous strings of the array. A balanced string contains equal number of vowels and consonants. All right. I want to walk through that one. Actually, the first one. Let's hold off on that for a moment. This one. How many balanced substrings? We have 3. A, B. There's one vowel, one consonant, so that's balanced. That substring is balanced, this substring is balanced, B and E, and if we combine those two, that is also balanced. So total of 3 balanced substrings. In this example, there are no balanced substrings. Now this string, the first one, has 2 consonants. This string has 2 vowels, but they're not contiguous, so we can't use those. Now this, let's see, how far can I pull this over and still see everything? Right about there. Yeah, okay. This is almost exactly like the subarrays with some k problem, where we could solve that with prefix sums. This is I actually just copied the code from that one and pasted it in here. Made a couple of changes to use vowel counts instead of sums, but let me say something about the getVowelCount. It's not actually getting the number of vowels in a substring. It's getting the number of vowels. Well, let's see. How many more vowels than consonants are in a substring? So that could be a negative number. I mean, for these over here, for example, A, E, I, O, that's a 4. A is 2. B, C is a -2. O, T, they're the same. So that's a 0. C, B, C, D, B, D, no vowel. So that is a -4. Okay. So that's what getVowelCount is doing. The rest of this, let's see. Let me get a pen here, and prefix sum. So we are going to have a HashMap, just as we did in the previous problem, the subarrays, and we'll add one entry to it right here. Count. Count and sum. All right, let's put those down here. Count, which is currently 0, and sum, which is currently 0. I guess I don't really have to put those down there like that. Okay, well, I got them now. All right, we're going to go through all the strings. For each string in the array, int vowel count equals get vowel count, and then add the vowel count to the sum. Now, the vowel count for this is 4. So we're going to add that to the sum. Okay. You know what? I changed my mind on that. I'm not going to keep track. I'm not going to keep track of these down here. Count is 0. Sum is 0. Sum is now 4. We'll keep track of it right there. Let's see, sum is 4, count. So we're going to look at the previous sums. Is there a 4 in there? And there isn't. So we're going to put a 4 in there. So we'll put in a 4 and number of times that we've seen it, which is 1. Okay, let's go to the next string. This has a vowel count of 2. Add it to the sum, and the sum is now 6. Let's see, count. Count plus equal previous sum, get or default. I'm sorry. Yeah, is there a 6 in the hash map? And there isn't, but we'll put one in now. So 6 and 1. All right, next one. This is a -2. There's no vowels. 2 consonants, so this is going to go to 4. Add it to the sum. Is that sum in the hash map? And in fact, it is. We have a 4 here. So count will now increment to 1. So that works because we got the 4 originally from right here. So that means if we just drop that out of this rolling sum, then A, B, C is going to be balanced. All right, prefix sums. So we're going to increment it. We just saw 4 again. So let's increment it now. It is 2. We're going to get the next number, next string, I should say. That has a vowel count of 0. 1 vowel, 1 consonant, so they're balanced. That doesn't change the sum if we add it, so is there a 4 in the hash map? Yes, and the count is 2, so we're going to add 2 to the count. All right, so the count is up to 3. How does that work? Well, the 4 is in there twice. That means, first of all, we can drop this A-E-I-O. We can drop that 4. And these 3 together at indexes 1, 2, and 3 are going to be balanced. We can also drop the 4 out here because the prefix sum up to here was also 4. We can drop that, and OT by itself is balanced. So now we have a count of 3. We will go to the next string. That has no vowels. So it has a prefix, it has a vowel count of -4, which takes this down to 0. Is there a 0 in the hash map? Yes. And so we will increment the count. Why does that work? Well, we just put that in there in case the 0, 1. We put that in there in case it turned out that there was a balanced substring starting at index 0, which in this case there is. If we add all of these up, how many vowels do we have? I mean, here we're at +4, we're at +6, we're at +4, we're at +4, and now we get 4 consonants. Put those in there, the whole thing sums to 0. All right, let's get rid of the writing. Just go back to this, and I'm going to scoot this over and try to run it. All right. All right, that's it. As I said, this is almost exactly like subarrays of some K. If you want to review that, yeah, we just do it with prefix sums and a hash map. So that's it. Please like the video, subscribe. I'll send you problems of the day every weekday, and we'll see you next time.